Hello guys, here Mr. G with another video. This time we're going to be solving question 4 from the question paper done in September 2023 at the Eastern Cape problem. But before we start, don't forget to subscribe to the channel and like the video. These questions say two trolleys, A with a mass of 1 kilogram and B with a mass of 2 kilograms are held stationary on smooth horizontal surface. So let's write out 4 important things there. First, block A is 1 kilogram. So this block have a mass equal to 1 kilogram. Let's write it there. And block B have a mass of 2 kilograms. This is mass B equal to 2 kilograms. And the other important thing is smooth. So frictional force, I'm going to highlight smooth surface, then frictional force is equal to 0. Okay? And then this is stationary on a smooth horizontal surface with a compressed spring between them, as shown in the diagram below. The spring is released and falls to the ground. The trolley A moves to the right at constant velocity of 1 meter per second and collide with a wall. So trolley A is going to be moving to the right. This one after, let's fix this one and let's write that information here. This one after is going to move that is after they release, and it's moved with a velocity which is equal to 5 meters per second. Okay, that is important. Assume that the system is isolated. So the system is going to be isolated, and the first question is define an isolated system. An isolated system is a system on which the net external forces is 0. Now question 4.2, calculate the velocity of trolley B immediately after the spring is released. So to do this one, we have to use the law of conservation of momentum. And we're going to do that one real fast, and we're going to do it here. And I'm going to write it here by 4.2. Now I'm going to start from the beginning, but you don't have to do that. And I'm going to start saying that when the net external forces is equal to 0, the change in momentum is equal to 0. It means that the total initial momentum is going to be equal to the total final momentum. All these are vectors, so let's write the symbol there. Okay, so now the total initial is going to be the addition of the initial momentum of trolley A plus the initial momentum of trolley B. Okay, and all that will be equal to the final momentum of trolley A plus the final momentum of trolley B. Alright, and now remember that momentum is the product of mass and velocity. So this will be the mass of trolley A multiplied by the initial velocity of trolley A plus mass of trolley B multiplied by the initial velocity of trolley B equal to mass of trolley A, final velocity of trolley A plus mass of trolley B, final velocity of trolley B. That is what we have here. This is the law. All that, guys, is the law up until then. Okay, now what we have here, we did write the data on the picture, so we don't have to write the whole data. Okay, the only data that we didn't write is that the initial velocity for A and B is going to be equal to 0 because the objects are not moving. They say that they are held stationary there. Okay, so that is important. Then at the end, we have that they're going to move in opposite direction. Okay, so we are going to write here also, and this is an important step, right is going to be positive. Okay, now let me say something. You do not have to write all that. You may start from here if you wish, and you will get full marks. Okay, I just start there because I wanted you to recall the whole law. Alright, so now let's substitute what we have. So here we have 1 kilogram multiplied by 0 because initially they are at rest. So mass B is 2 multiplied by 0 because it was at rest. Now this is 1. Remember the velocity, the final velocity of the trolley is 5 meters per second. when the spring is released, mass B is 2, and you are looking for that final velocity of object B. Okay, so when you do that, this is 0, this is 0, you will get that 0 is equal to 5 plus 2 final velocity B. And then, guys, if you rearrange this one, it's minus 5 divided by 2 is equal to the final velocity B. And then the final answer is final velocity B is equal to minus 2,5 meters per second. Okay, now what does the minus mean there? Minus means direction. Okay, we say that right is positive, therefore minus means left. And then we're going to write it in that way, because I know in the memo they like it like that. So let's write final velocity is equal to 2,5 meters per second left. And that is the final answer. Now note, you cannot say, and I explained this in one of the previous videos, you cannot say negative 2,5 left, because negative 2,5 left will mean right. So you take off the negative and you give the word the direction, okay? So that is question 4.2 is quite simple, and I hope it helped. Question 4.3 say, the average force exerted by the wall on the trolley is 80 Newton, and the collision of the trolley with the wall lasts 0,5 seconds. Calculate the velocity with which the trolley move away from the wall. What? Very good question. So what we have here, this is question 4.3. Let's do it here. We have a trolley. Let's make this is the surface. Okay, there is a wall. Let's say the trolley is moving initially in that direction with a velocity equal to 5 meters per second. Now this will be the initial velocity of trolley A. Okay, this is trolley A. It's moving there and eventually it's going to bounce on the wall. Okay, when it bounces, it will bounce with a specific velocity, and that is what they want. In this case, they're telling you that the time of interaction with the wall is equal to 0,5 seconds, and they are telling you that the average force, I'm going to write F net in this case, I'm going to write F net, but it's the average force is 80 Newton. Okay, they ask you to calculate the final velocity of the trolley. So let's do that real fast. Now, when you do this work, I always want you to go to the formulas, guys. Now, we are under the topic of forces. There is when you will find the formulas of a momentum. And which one is the one that can help us? Well, here is the one that can help us. This is the formula that can help us in this specific question. Now, something important, remember, that momentum or change in momentum is equal to impulse. Okay, is equal to impulse. I don't see here the formula for impulse. It should be there, but I don't see it. Now, impulse, remember, is equal to the product of F net and time. The thing is, they call this one just impulse. That is why the formula is not there. Okay, so impulse also in some places can be used the symbol J. In many countries, J is the symbol for impulse. So that is the formulas we are going to be using there. So we are here and we are going to start combining. The first thing we're going to write is that the impulse is equal to F net multiplied by time. That is the formula for impulse. Okay, and then if we combine, we also remember that impulse is equal to change in momentum. Okay, so if we substitute here, and these formulas were there, guys, so we have that change in momentum is equal to F net multiplied by time. Now, change in momentum, how do we calculate the change in momentum? That will be the product of mass and the change in velocity of final velocity minus initial velocity. Right? But let's not write it later. Let's write it rather mass multiplied by the final velocity minus mass multiplied by the initial velocity, and this is going to be equal to the product of F net multiplied by time. And I think, guys, now we have everything that we need to answer this question. Remember, we are looking for the final velocity. That is the question mark here. Now, once more, before we do any substitution, we must take direction. And let's take, for instance, right positive. Let's keep right positive for this question as well. And therefore, the initial velocity is positive, and that's it. So let's substitute what we have here. All right, so we have the mass, which is 1. So it's 1 multiplied by the final velocity, which is going to be final velocity. Let's write it with the 1. Minus is minus, let's keep the symbol there, minus 1. We're still working with the same work. The initial velocity is 5, in this case, equal to F net, which is 80. But be careful, because the wall exerts a force on the car which is to the left, because the wall pushes the car to the left. So here, this one here is going to be left, and therefore, if we come back to the direction, this is negative there. Okay, so it's a negative 80 multiplied by the time, which is 0.5. There we go. Okay, now it's correct. So let's substitute, let's calculate, sorry. Okay, so when we do this calculation, we are going to get that is final velocity minus 5 is equal to minus 40. If you rearrange, you get that the final velocity is equal to minus 40 plus 5, which is 35. Final velocity is equal to minus 35 meters per second. In the question, they ask you to calculate the velocity, also have direction, and therefore, if we fix, remember the minus there have a meaning, which is direction. So the final answer here is going to be 35 meters per second left. Okay, so let's write the answer somewhere there. Use another color so you can see it. The final velocity is equal to 35 meters per second to the left. Now, important, this number is a little bit too big, so I think the problem here is with the time. The time is too big. The time is supposed to be 0.05, but we answer what is in the question paper. So according to that number of time, this is what you should get. Okay, so that is the answer. Question 4.4, a learner comments that a collision of a trolley A with a wall is inelastic. Briefly explain what it means by inelastic collision. All they want to know what is an inelastic collision. And all we have to say about inelastic collision, that is a collision where the kinetic energy is not conserved. Kinetic energy is not conserved. That is for inelastic collision. Guys, this is the end of the video. I think there is a problem here with the time, but we work with the time that they gave us in the question paper, and it is not a big issue. It's not a big problem there. But thank you for watching. I hope it helped. This is a good question to practice about momentum. Subscribe for the channel, thumb up. I'll see you next time. Mr. G here.